Hi, my name is Warner and I'll be your chemistry tutor for this problem. When we're trying to understand what stoichiometry is, it's basically an area of study that allows us to quantify the amount of product that can be formed from a chemical reaction. The fundamental aspect of chemistry is that they act with one another and they form a product. In this problem, we're focusing on potassium hydroxide and nickel 2 sulfate. Right away, we can focus on the charges of potassium, which is +1, hydroxide, which is -1, nickel, which is +2, and sulfate, which is -2. This is going to come in useful when balancing. We're trying to find the compounds first, then balancing the whole entire reaction. So charges are balanced, compounds balanced. Nickel +2, -2 with sulfate, compounds balanced. +1. There's two potassiums to equalize the -2 charge from the sulfate, +2, and two hydroxides to compensate for the +2 charge of nickel. So there's two hydroxides in each side, one sulfate, one nickel, and two hydroxides in each side. So the whole reaction is balanced. And from this reaction, we can find the mole ratios, which is going to come in useful when doing the stoichiometry aspect of it. So in part A, we're trying to find the limiting reactant. So what really is a limiting reactant? The limiting reactant is essentially it's essentially a reactant that runs out first and limits the amount of product that can form. In this case, the product is nickel hydroxide, which is a precipitate within the aqueous solution of potassium sulfate. So from the reaction, we have 100 milliliters of potassium hydroxide that's already given a concentration. So we can cancel out the ml, find the amount of solution, times the concentration, and we get the mole. So we do the same thing for nickel sulfate. So we have two mole quantities, the mole quantity of potassium hydroxide and the mole quantity of nickel sulfate. So then from these numbers, we're trying to find which reactant produces the least amount of moles of product or precipitate here. So 0.02 moles of potassium hydroxide, using the mole ratios that we find that potassium hydroxide produces the least amount of precipitate or nickel hydroxide compared to nickel sulfate. So we find that potassium hydroxide is the limiting reactant. So for part B, we're trying to find the theoretical yield. What do we mean by theoretical yield? The theoretical yield is the maximum amount of product that can be formed from a limiting reactant. So using what we found earlier, we use this number of 0.01 moles of nickel hydroxide and use the molar mass of nickel hydroxide. We can simply do this by the atomic masses from the periodic table. And we find that it's 92.706 grams. So using molar mass, we find that 0.93 grams of nickel hydroxide are produced from the limiting reactant. So this is our theoretical yield. So that's the answer to part B. So in part C, they're approaching this problem in the form of an experiment. So the products is simply potassium sulfate, which is an aqueous solution. So it goes down through a vacuum filtration to take out the nickel sulfate or nickel hydroxide, right? So the filter paper and the nickel hydroxide are left above here, while the potassium sulfate goes through the filtration. So what's left is the mass of the filter paper and the nickel hydroxide. So to find the mass of the nickel hydroxide, we just simply subtract whatever number we find, which is 1.6, with the mass of the filter paper, which leaves us with the actual yield of nickel hydroxide. So to find the percentage yield, we simply use this equation, the actual yield over theoretical yield times 100. So using the numbers that we obtained from the theoretical yield and the actual yield, so we divide the actual yield with the theoretical yield times 100, we get 84%. So in summary, to solve limiting reactants equations, we write a balance equation. We find the moles of reactants from the given molarities and concentrations in the problem. Using mole ratios, we find which one produces the least amount of moles of the product. This will be the limiting reactant. Theoretical yield, just convert mole of product to grams. Actual yield is experimental and may vary. and the percentage yield is simply the percentage of actual yield over percentage yield times 100. Thank you. Hopefully you found this helpful. See you later.